Next, we're going to call up Mike McConville.
All right, well, good evening, everybody. I'm really honored to be here. This is actually the second year in a row that I've taken part in the Indie Galactic Space Jam. Last year, of course, it was in concert with Nerd Night Orlando, and so it's great to be back here. On Tuesday, I had no idea I was giving a talk tonight, and then here I am tonight, so it's great. And so tonight we're going to talk a little bit about the future of human exploration of space. We've been in space now for a while, started all the way back in 1961, and so a good place for us to start. I'm the coordinator of the planetarium over at Seminole State College, and my other job is I teach history at UCF. And so I have some students here tonight, so hey guys, I'll see you on Tuesday again. And one of the things that I really do love is talking about the past. It's what historians do better than just about anybody else. And so you can kind of see a few of the greatest hits of human spaceflight over the last 55 years. And so our first person all the way on the left is Yuri Gagarin. He is the first person to orbit the Earth, the first person to make it into space. April 12th of 1961, an incredibly important day in the history of humanity. If you're familiar with Yuri's Night, of course, this is the namesake. Next to him is John Glenn, the first American to orbit the Earth, orbits 3 times in 1961. In the middle is Apollo 11. That is the Saturn V rocket taking the first men to land on the moon. Neil Armstrong and Buzz Aldrin, with Michael Collins up in the command module orbiting the moon for 42 minutes. In a lunar orbit, Michael Collins became the first person ever to be completely divorced from every other person in existence. He took a picture that included the 2 men on the surface and the Earth. It is the only picture in which Michael Collins is not part of it. So it's everyone who's ever existed minus Michael Collins. So a very unique situation for Collins to be in 1969. The fourth one is the very first launch of the space shuttle. That is April 12th of 1981, and it opens up the era of reusable spacecraft, something that we're still living in today. And then, of course, there on the far right is the International Space Station. It is roughly the size of the Citrus Bowl, mainly because I refuse to call it Camping World Stadium. But it's the Citrus Bowl. It's about that size. It is one of the most impressive pieces of scientific technology we've ever been able to put together. It is truly an international space station. It is a sign of what countries are able to do once they get that whole, political and economic problem out of the way. And so this is what we've done. This has been the last 55 years of human spaceflight. The present, if you listen to some people, and especially the prognosticators that were outside of Florida at the end of the shuttle program, you heard a lot of doom and gloom that it was the end of the Space Coast and Brevard County would cease to exist, and we would never, ever get back to space. Because, of course, we have to rely on those Russians. We'll send the Soyuz spacecraft, which has been in development since the 1960s. It's an oldie but a goodie. It's what we use today to get American astronauts to the space station. The Soyuz capsules stay connected to the space station. They're essentially the escape vehicles if anything should go wrong. But the Russians have maintained an ability to put people in space for the entirety of their space program. It doesn't necessarily mean they're better than what the U.S. has been able to put together. They've just had this ability for an uninterrupted amount of time. We're also seeing elsewhere in the world the emergence of the Chinese Space Agency. And so today, at about 10:05 our time, the Chinese Space Agency launched their new Taigong 2 space station. It was a successful launch. It is their movement towards a modular space station, just like the one that we currently have in the ISS. It's a really big deal. They sent their first astronaut into orbit several years ago, and the Chinese have a capability of being able to put people in space at this point. And then here in the United States, we have Spaceship One. We're now, of course, in the realm of Spaceship Two. It's the private companies. This is Virgin Galactic. This is not an orbital spacecraft. This is suborbital. You don't actually get too far into space. Our very first astronaut in American history was Alan Shepard. He didn't actually make it into orbit. He made it into a suborbital ballistic trajectory because our rockets at that point didn't have enough thrust to be able to get him into the orbit he needed to go. We had to wait a little bit longer until John Glenn was able to do that. And so right now, if you listen to everybody, it's a terrible time to be in the United States when it comes to space exploration, especially human space flight. That we have no control over our destiny and there's not much left for us to do, and that we just keep waiting for things that don't ever seem to show up. And that's where the future is a little bit better for us. So we've got some great stuff going on. And of course, being that it is the 50th anniversary of Star Trek, the whole presentation is entitled to Boldly Go. The future is going to be pretty great. We've got a lot of amazing programs in store over the next couple of years, over the next couple of decades. And probably the most famous one, certainly currently here in Central Florida, is the SpaceX Falcon program. The Falcon 9 is one of the more impressive pieces of technology the last couple of years, to have a private company that's able to successfully put things into orbit. They're currently working on what's known as their Dragon version 2 capsule. It's going to be able to have crews that are sent up to the space station. They entered into a contract with NASA a few years ago to be able to have this private industry working with NASA to be able to get Americans back into space in the next couple of years. And so we should be able to see this Dragon space capsule in use within the next 2 to 4 years. And because it is a SpaceX design, it is as impressive on the inside as the technology would be on the outside. It is truly science fiction. They couldn't do it any better than they did here. So it looks nothing like the old Apollo modules, the Gemini modules. There's a whole lot of screens and buttons and really interesting looking racing chairs. And so, you know, if we can fault Elon Musk for anything, it's that he likes to make it look pretty. I don't know if this is going to be the actual production of it, but at the very least, you get an idea of what the SpaceX aesthetic is all about. But in utilizing these private companies to work alongside NASA, what we're able to do is to bridge the gap between the newest NASA systems that are going to be coming online in the next couple of years. That is going to be one of the more important let's see, hopefully we get there. We go. Probably the single most important rocket program in the history of the United States. This is the Space Launch System. It's currently going to be the rocket that will not only take us back to the moon, it will take us to asteroids, and eventually should be able to take us all the way to the planet Mars. The Space Launch System grew out of a program called Constellation that was canceled back to the beginning of the 20-teens. This is a modular system that honestly bears a striking resemblance to the solid rocket boosters and the external fuel tank of the space shuttle. And there's a good reason for that, because it's essentially the same thing. It works out great. This is a little bit cheaper for us. It still allows us to put close to 140 tons of payload into a low Earth orbit. So to give you some sort of comparison, the Saturn V, biggest rocket that's ever been launched, had a payload rating of about 140 tons. The current Falcon 9s have a rating of about 30 tons. And so there's a huge difference into what you can put in space between 30 tons and 130. At the very beginning, the SLS is supposed to start here about 2018. The next few years, we're going to see the launch of one of the biggest rockets in the history of mankind. It's going to be pretty awesome. And once we do get this system off the ground, NASA's decided that we're going to use all of these rockets going forward for our human spaceflight and exploration of the solar system. So as you kind of move from the earliest settings over towards the right, that Block 2 cargo system is 365 feet tall. That puts it 45 feet taller than the Statue of Liberty. It is 25 feet taller than the Saturn V. It will produce more thrust than any rocket that has ever existed. And in that setting will be more than enough for us to begin the process of getting humans out towards Mars, out into the solar system for the first time. And so one of the things that Dr. Britt talked about, of course, with asteroids, is the idea that in a few years, one of the major plans for human spaceflight is to bring astronauts to an asteroid that has been towed to Earth. We've put it into either a lunar or an Earth orbit, and that what we'll be able to do is to go to this asteroid, work on all of the sorts of things that are going to be necessary for us to be able to safely and effectively get to Mars, and mine the sort of materials on those asteroids that have very, very limited amounts here on Earth, but are extremely common in the asteroids of our solar system. And so one of the estimates that came out a few years ago from, of all places, the General Accounting Office of the United States government, stated that if you had a 100-meter asteroid and you were able to mine it of all of its usable resources, it'd be worth between $1 and $3 trillion. It's a lot of money. Of course, if you put all those resources in the market, it might drive prices down, and then it's not worth $1 to $3 trillion. But the fact is that you can have a football field-sized asteroid that could pay for the entire mission by itself. And what we learn from those sorts of missions is going to be incredibly useful for us moving forward. But it's not just this huge system that's going to be able to get us out into space. There is a crewed capsule that is going along with it. This is the Orion Multi-Purpose Crewed Vehicle. It is striking resemblance to the old Apollo modules. And there's a reason for that. They were really, really good designs back in the 60s and 70s, and they are really good designs today. They're bigger. There's a little bit more space for the astronauts. You wouldn't want to go to Mars in just one of these. And so we'll build attachments that will allow for a lot more space for the astronauts, for the ability for them to hold all of the necessary gear and water and food for what could be an 8-month journey to the Red Planet. But in just a few years, the United States is going to have one of the most capable spaceflight systems it's ever had. And that's a really, really important thing for the Space Coast and for Florida and for the exploration of the solar system in general. I would say between the SLS and SpaceX and Blue Origin and all of the companies that are deciding to come back to Florida and really make this the place for space yet again, things are actually going really, really well for us. You can even go to companies like Boeing that won a contract several years ago from NASA to build what's known as the CST-100. It is a crew transport vehicle that's going to sit on top of an Atlas V rocket. We just launched one of those last week for OSIRIS-REx. It's a spacecraft. It's going to go visit the asteroid Bennu, and it's actually going to take about 4 or 5 ounces of that asteroid off of it and transport it back to Earth in 2023. It's really impressive. And so not only do we have all of these different capsules that can work on all different types of rockets, and we have huge systems with more than enough power to get us to our closest planets, the rest of the world is doing that with us. Now, one of the things that was a huge problem back in 2011, there were a fair number of people who had a huge problem with this, is that if we canceled the space shuttle program, a program that was incredibly expensive, we lost 2 orbiters, to be able to launch and get an orbiter back to Earth and ready for the next launch took between $1 and $2 billion each. NASA's budget, if you're aware of what's been going on over the last couple of years, is not that big. I think now we're up to $22 billion. It sounds like a lot of money. NASA could use twice that, 3 times that. And so after a while, if you're spending $2 billion to be able to get an orbiter back into space, there's probably better ways of utilizing that. The thing is that the 6 years between the space shuttle program and the next chance for the United States to be able to get people into orbit on a U.S. spacecraft is exactly the same amount of time that separated the end of the Apollo program in 1975 and the beginning of the space shuttle program in 1981. Nobody was complaining back in the 70s that we were losing ground to the Soviets or that we had given up the forefront of space exploration. It happens. Spaceflight gaps are real. We can send up a rocket that's not well tested and we can kill a bunch of people, and then nobody's getting into space ever again. Or we can do what we're supposed to do, put the best programs out there, and try our best to be able to make sure that our exploration of the solar system is good for the next 50 years. And so, where are we going with all of this? Well, for one, we are influencing the rest of the world quite well. We are looking at the possibility of astronauts from countries you wouldn't necessarily expect over the next 10 to 15 years. The Indian Space Agency is remarkable. Just last year, they launched a rocket that released 23 different satellites at once into orbit. It's the most satellites that have ever been released off a single rocket. They're expecting to get a human in space by 2021. Depending on how things go over there, Iran is talking about putting people in space. If you have a big enough rocket to shoot a warhead into another country, you can probably get somebody into suborbital space. You build it a little bit bigger, you can get them into orbit. And so maybe North Korea will someday put people into space. They can put Kim Jong-un on the top and make it really, really easy on all of us. And Japan is looking to get a human into orbit by 2025. And so you can look at this in a very nationalistic way and say, well, the United States should be at the forefront of it, and that's how it's going to be. Or we can realize, and kind of using the Gene Roddenberry view of the universe, that at some point we'll forget about all of those political lines, and that we're just a world that works together to be able to find this greater good, to boldly go where no one has been able to go before. And one of the places, of course, that we want to go more than anywhere else, really the end-all, be-all of exploration at this point, is Mars. Between the publication of The Martian, and of course the movie that came out just I want to say it was last year, Mars is the place we've always wanted to go. It's where the little green men came from. And it's the War of the Worlds in 1939 with Orson Welles in New Jersey. Aliens have invaded New Jersey and they're heading towards New York City. And people didn't know that it was a joke and they panicked. They shouldn't have panicked, of course, because as we all know, you don't travel millions of miles to land in New Jersey. Not intelligent life. And I'm from New York, so I'm allowed to say that. But Mars is where we really want to end up. And eventually, the SLS and these other large systems are going to be able to get us there. There are some big problems with going to Mars. The biggest, of course, has to do with the fact that it takes a long time to get there. Even with the best systems we'd be able to produce in the next 20 or 30 years, that trip is about 4 months one way. If we use the systems we currently have, we're looking at a 6 to 8 month journey. And then if you get there, you don't stay for 3 days and turn around. It's not very efficient. And so what you might end up doing is spending a few weeks on the surface. You want to start up some scientific laboratories and get things going there on the surface for future missions, and then you've got to make it all the way back. And so these systems that we're testing now are going to be far more effective in the next decade and a half as we start going towards asteroids. We've got to prove the concept first. And so within probably 2025 to 2030, we're going to start to hear a whole lot more about the United States going and capturing asteroids and bringing them back to lunar orbit or to the Earth, and us mining them. And all the things that we learn from that are going to be playing a very, very huge role in how we go and visit Mars. To quote Mark Watney, probably the only way that we're going to be able to do this is we're going to have to science the shit out of all this. And that is precisely what I think NASA and SpaceX and Blue Origin and Russia and China and India and Japan are doing so effectively now, that the future of human spaceflight is very, very bright. We are going to be off this planet in no time at all. And so while our parents and grandparents, for most of us in here, experienced the Apollo launches and the moon landings, in our lifetimes we're going to be experiencing things that are going to be equal to that, that are really going to re-inspire the love of space and the universe, and to reignite that fire of exploration that has been a part of the human experience for as long as humans have been around. And so if you're worried that we're not going anywhere quick, you're in for a fun ride over the next couple of years. And so let's get a little bit more excited about all of that as we move forward. And so should be a really good time over the next few years as we take our way off of Earth and back out into the solar system. So thank you guys tonight. And if we want to do any Q&A. So any questions from the audience tonight? And since it's kind of dark, can't see your hands, so go ahead and yell out.
Okay, so this question can be for either the first two speakers. Both of you mentioned being interested in meteoroids. And I was wondering, what information can you gather from a meteoroid?
So from a meteorite here on Earth, or an asteroid out in orbit, and I will very, very quickly defer to Dr. Britt if need be. They are, in a lot of ways, kind of fingerprints of the very earliest part of our solar system, the earliest times of our solar system. And they're a very good indication of what the conditions were like early on in our solar system. And for us to understand how our solar system came to be, how the planets formed, these asteroids hold a lot of those answers. They're going to produce way more questions, but that sort of knowledge allows us to take that out of our solar system. And as we're finding thousands and thousands of new exoplanets, solar systems outside of our own, we get a better understanding of how those solar systems come into being and how planets evolve and whether or not the conditions we see in our solar system are unique or if they're kind of par for the course in our Milky Way or in the universe. And that has very big implications on the eventual search for Earth-like planets and for the possibility of life in any form. We want to know if our conditions are similar or different from the rest of the Milky Way, the rest of the exoplanet systems. And so those asteroids give us a very distinct and unique view into the history of our solar system. And so it is a point in time that is frozen in these rocks. And, you know, we can think of them as floating rocks in space. They are literally one of the great stories of our solar system. And they will tell great stories for many, many years to come.
Thank you.
And they're worth a lot of money.
Yeah, if you do it right.
Any other questions?
Yeah, I was wondering, you talked about the SLS, and it kind of seems like a bigger and better Saturn V rocket system, pretty much.
Essentially.
Is there a reason why NASA's going with that? And I was wondering if they were considering any other propulsion methods in terms of, I know the EM drive is untested and that sort of thing. There's been a talk lately about a ground-based laser system like instant install probes and that sort of thing. But I was just wondering if they were considering any other sorts of propulsion.
NASA's been considering all sorts of different propulsion systems. But one of the things that oftentimes gets lost in all of this is that you can ask for the greatest propulsion system that's ever been created, but you've also got to pay for it. And with the limited budgets that NASA's been given the last couple of years, you go for tried and true. The systems that worked for the space shuttle worked pretty well. If you refine those, then you end up with an SLS that is dependable, that you don't have to retool everything for. Many of the engineers that could work on the shuttle can work on the SLS with a little bit of extra training because there's a similarity there. It keeps the prices down. It allows us to have this commonality where we have no idea how this works, to we know how it should work. And we've been prepared for this before. We've got systems in place and launch pads that work for this kind of system. And since NASA's not going to get $100 billion a year in funding, if you can make it efficient and if you can keep those costs down, that's the system we're going to go to first. At some point in the future, hopefully there'll be breakthroughs in this, or you'll have a private company that's able to develop this on their own. But as of right now, it's really about the value. Why haven't we been back to the moon is one of the great questions. There were 2 additional Apollo missions planned after Apollo 17. They were canceled by President Nixon, not because he wanted to protect the fact that there was like Sentinel Prime on the back of the moon or some stupid Transformers thing. They were too expensive. In today's money, the entire Apollo program cost $150 billion. And so we are working within those constraints. The fact that any of this is happening at all is testament to the hard work that these engineers have been putting in for decades at this point, to be able to produce systems that work and work and work. It worked for the space shuttle. We did have 2 catastrophic failures. One of them we were able to fix fairly easily. The other one we knew could happen with the Columbia reentry. Not an indication of the system not working. It's simply, if you're putting people in space, it's a dangerous thing. And if a rocket explodes on a launch pad, it's not because the rocket isn't good, it's because this is a very difficult thing to do. And the fact that it's not happening every time they send a tube filled with explosives into space is a pretty good thing at this point. So we're keeping it cheap at this point.
Great. Yeah. One more?
How would you compare, like for a sense of scale, a kilometer long asteroid towards like the metal that we have on Earth? Like, what's the scale-wise? What would have more, and what would the difference be?
So one of the elements on Earth that's exceptionally rare on Earth itself is iridium. Asteroids, especially the heavy metallic ones, have large amounts of iridium. And one of the ways that we can kind of gauge how much iridium would be in an asteroid is because around the Earth, geologically, there is a line between the Cretaceous period and what's known as the Paleogene, what used to be the Tertiary period. It's known as the KPG boundary. It is the point in which the dinosaurs disappear. And there is a level of iridium in this layer of clay across the entire world that is considerably higher than any iridium concentration we'd find anywhere on the planet. And so you do a little bit of math, you see what that iridium concentration is like. And the iridium concentration in this KPG boundary is, depending on where you are, between 20 and 2,000 times the concentration of iridium that would naturally occur on Earth. If you go and look around the planet and you find that there's a crater that's about 150 miles across, that's about 66 million years old, which is right at this level. It's in the Yucatan, it's called the Shishilu crater. It is the crater of the object that hit the Earth that killed off the dinosaurs, or at least helped to kill off the dinosaurs. And we can figure out how big an object would you need to make something that big, about 6 miles across. If we were looking at that. And so you look at this 6 mile wide rock, maybe 10 kilometers, and how much iridium's in that, we can start to get a sense of what concentrations we might see in some of these asteroids across the rest of the asteroid belt compared to here on Earth. And so there's a lot of rare earth metals that would be considerably more apparent in these asteroids than they would here on the planet. But the other thing is that vast majority of these asteroids are comprised mainly of iron. We have a lot of it, except that, pulling it out of the ground on the surface is not something you can do usually. And so we have these asteroids that have very, very clear compositions that we're able to figure out from these meteorites and then apply them across these big classes to know what it is that we're likely to see once we get to the asteroid belt.